Good morning, everyone, or afternoon or evening, whatever it is, wherever you are. Welcome to the Microservices Choreography and Triaging Errors with Elastic Observability and the Elastic Stack. Oh boy, I said that all in one go. I'm happy with myself. I think this is all I'm going to do today. Thank you very much. Now, since you guys are here, I'll probably present anyway further. So the presenters, myself, Salman Ahmed, before the world went into this got stuck between this rock and this weird place. I used to just sit on my desk and pretend really hard that I'm doing work as a solutions architect. It's very difficult these days, but I'm somehow managing. I work at Brolly, and with me, I've got today Omid, who's a software engineer. He doesn't pretend to work; he really does the work. He's pretty good at it as well. What are we going to be talking about today? We're going to be talking about our logging journey in Brolly. And on the agenda, we have about Brolly, the triple W. So basically, what is Brolly? Why does it even exist? And who uses it? We're going to talk about how we actually have this problem of triaging, collecting errors and triaging errors, then the solution, the version one of the solution, the version two of the solution, which is obviously powered by Elastic. That's the whole point of the thing. And then there's going to be a demo by Omid actually on how we error triage in Brolly. And then finally, some lessons learned and some takeaways. So what is Brolly? Brolly is a social media archiving platform. In essence, what we are giving to our customers is the ability to save, archive their social media records, whether it be Facebook, Twitter, Instagram, YouTube, LinkedIn, all the likes, and their messages as well. And then they can export them. They can have some insights and analytics on them. So that's in a nutshell, Brolly. That's why everything in Brolly is about a record. You'll see later on me talking about records a lot and replaying records a lot. So all of that is related to basically the bread and butter of Brolly, which is the captured records from social media for our clients, and archiving them and saving them. And who or why actually they use Brolly, people use Brolly. In a nutshell, legislative compliance. There's a lot of legislation around archiving your social media, and the requirements to actually how you were supposed to do this. And basically, that's what Brolly offers. And that's the reason why you'll see on the next slide that a lot of the customers of Brolly and the people who use Brolly are actually government departments. So majority of our, since we are Australian based, majority of our customer base is here in Australia, the state of Victoria, the state of New South Wales. So we've got lots of clients, but all over Australia, we've got clients, and we've got clients in New Zealand as well. And we're trying to make headways into various other sectors as well and all over the world. But yeah, that's the lay of the land. That's the triple W's of Brolly. Let's move on to the actual problem of today. Now, this picture, I had a long chat with our design team. I think it's a passive aggressive way of envisaging the problem that we've been living with in the past 2-3 years. But apart from that, it also tells you a journey that we've had with actual errors in our platform or any platform. And the key to our platform is actually the microservices based architecture as well. But I'll talk about this on this slide actually, where we're seeing the lay of the land of this whole problem with errors. So the first issue that we are faced with is actually what and how to log it. And in microservices, there's microservices challenges, but then there is also lots of other stuff as well. There's the web logs, there's your metric logs, there's network, performance metrics, there's all these different things. All of it, we want to log everything and we want to know about everything. Microservices in its own self presents a deeper challenge to it as well because of this whole distributed nature of the services. And then when we're deploying it into a Kubernetes cluster, everything is spread out. We've got what we usually say, just you have E equals MC square, we have L equals SP square. So number of logs is directly proportional to the number of services and the number of pods they're deployed on. So there's heaps of logs. They're deployed all over the place. Not all over the place in our infrastructure, but you get the gist. It's all over. We've got to collect that information somehow. So it's the application logs, it's the actual user logs as well, and lots of metric logs. And then we move on to, okay, we've collected these logs. how do we triage and visualize them? And when we're talking about triaging and visualizing, we have different viewpoints. So our business has different viewpoints. Business wants to know, just make sure that data quality is there. And if there is a problem, things are resolved quickly. Whereas the operational guys, they're concerned about the uptimes and Kafka metrics and all these different things. And once we've triaged and visualized our error and prioritized them, then we've moved to the next step. Okay, now we found the issue. How do we fix it? Do we automatically fix it? What kind of issue is it? Is it an app issue? Is it an infrastructure issue? So that's basically the lay of the land. And when we did deploy Brolly, we had our version 1 of this thing. And what was version 1? The version 1 was basically a combination of Brolly, Grafana, Nagios, CloudWatch, and my favorite, Vim. Because all you have to do is just tail the logs on Vim and just leave them on your screen. You look like a hacker. Everybody thinks you're doing work. And let's not just get into it that much. That's all my trade secrets. But anyway, moving on. Brolly error triage version 1.0. So as you can see, for each of the different boxes, we've got different platforms or different things that we were handling things with. For triaging, we've got your Grafanas and CloudWatch, and even custom dashboards for the actual logging. We had the Nagios, Grafana, CloudWatch, so lots of stuff. And then eventually for the actual resolution, it was all manual, basically. That's why you've got the Brolly logo big over there. And we've got the AWS infrastructure side as well, handling some of the infrastructure stuff, such as auto scaling and restarting of services and deploying of services. The problem that with logging with that kind of a spread out platform is that you've got lots of services, you've got lots of different softwares to maintain, you've got lots of different things to look after. And then when you actually go to find something, it's the same problem. You have to look at different dashboards, you have to look at different systems to actually find the problem, whether it be Nagios, Grafana, CloudWatch, or some central platform or some central dashboard that we have in Brolly. And then resolving, same problem. We had to, we could do it, but it's just took a lot longer, resolving could take days instead of hours sometimes, just because we'll have to manually replay the records. And that's with the Brolly's data pipeline, where we're capturing the record and we're enriching them across different microservices at each stage. So yeah, replay was a big problem as well. And then prioritizing the task. We had to sift through the multiple systems as well to figure out everything. So with all of that knowledge, with all of that lessons learned from the version 1, we went on to version 2, Brolly and Elastic. What did we do? What did we do this time? We replaced everything with Elastic, basically. So one size fits all. It's lots of different technologies within Elastic that give us the ability to log. So for example, you've got your Beats platform, which has got FileBeat, MetricBeat. Then for the triaging and visualization, we have Elasticsearch, we have Kibana. And then we built within Kibana the ability to directly contact our replay handling services to replay records directly, which is a demo that Omid will show you later on. And then part of the infrastructure as well. And we're working on actually connecting our infrastructure to our Kafka cluster as well at the back end, so that we can directly replay, we can directly actually monitor and scale up resources, microservices based on that. But that's part of the work that we're doing with maybe version 3.0. But yeah, that's basically it. And what did it give us? Basically, one ring to rule them all. If you don't know that reference, I would recommend watching the movie Lord of the Rings. That will be 9 hours of your life well spent. And if you've already watched it, you can spend the rest of your life thinking about why wasn't Frodo taken to the mountain by the eagles in the first place? So yeah, anyway, that's just my life. I'll think about that rest of my life. But moving on, it's the journey that matters. So what was the journey that we had? And with this one ring to rule them all, what we found out that we basically have a centralized collection of all our logs. So that's the first point I was talking about. Everything in one place, everything we can see and go and see in one platform rather than sifting through different systems and trying to find stuff. Easy to deploy and manage the agents as well. So that's basically coming from me. So I'm usually looking after the operational stuff as well. So all our Kubernetes stuff, we basically have simple FileBeat, MetricBeat deployment files that are just stock standard coming from the documentation or the publications of Elastic themselves. And all we have to do is just deploy Kubernetes services onto Kubernetes, which are taken up by the Beats platform. That's the second logo. Then that all goes into Elasticsearch, and then it all gets visualized in Kibana, which is the second to last logo. And then finally, the final person that you see there, that's me just being happy. I think I'm that cute, but my wife thinks I'm just a little bit more fatter and balder. But yeah, anyway, jokes on her. We're married for 9 years. Moving on. Intuitive interface and a query language that actually works really well for us, and we're able to find things very quickly, very easily. You just need to put your data in there, and then yeah, you can find it very easily. The time filter, you can see there, we're searching by an organization ID. It's very small, but you can get the idea. It's quite good. All these dashboards, a lot of these things are just coming out of the box from within the visualizations of Kibana. We can easily create alerts and watches on known errors and events. It can alert us via email or Slack, and then we can take action. Pretty much, that's how simple it is. And again, Omid will show you an example of that in his part of the presentation and demo as well. And context, that's one of the things that we learned basically, was that because we can push our custom context with our logs, it really helps. I cannot emphasize this point enough. So you can see in this picture, there's lots of different context level log message, but there's also this organization ID or a source record ID and things like that. They really help us identify an error or any record that moves across this pipeline that I keep talking about, where we've got, we capture the record, we enrich it across different microservices. We've got like dozens of services. Probably last count, I think we had 60 different services that are acting on that one record. So if anything goes wrong at any place, basically this context is through which we will track it, that, okay, that's the record ID or the trace ID. Show me wherever it is. And later on, again, Omid will show you how it actually very clearly maps that all out for us. And that's all out of the box, but we have to contextualize the logs. So yeah, contextualize your logs, and Elastic gives you the ability, and it's really good. So yeah, once we've got all that information, how do we actually resolve? And the resolution has become easy peasy lemon and squeezy. How is that? Well, we can first of all very easily correlate everything. That's what I was talking about. When we have the context, we can easily correlate an APM. APM is amazing. So we've got APM deployed in all our services, whether it's the Java agents or even in the web UI and the using the RAM agents, real user monitoring agent of APM. All the information comes together in here, and then we can easily correlate logs. We can track the entire life cycle. It's quite good. We can identify individual issues within APM. You can see that whole chart. I remember in the old times, before this version of the logging, we used to have like a hand-drawn picture on one of our walls in the office, overlooking the whole architecture. And whenever anything would go wrong, we would always look at that and say, maybe that service or that service. Over here, we basically just Elastic draws that out, Kibana draws that out for us in the APM module. And we can see, okay, where things are going wrong and where things are not going wrong. And then when we do find them, we've basically built this functionality within Kibana that we can click a button and just replay the record after, obviously, we've fixed the error. And yeah, the ability to find these errors quickly, it just reduces our time to resolution. We're able to very quickly resolve things and respond to problems, and that really helps us. So with that, I think that ends my part of the presentation. I'll hand you over to Mr. Omid, who is going to give you a demo, and who, unlike me, I guess really likes to press buttons. So there you go, a demo of logging and error triage in Kibana with Omid. Thank you very much.
Thanks, Salman. Thanks for the introduction and for the transition. And now we are going to have a quick demo on how we are easily detecting and resolving errors in Brolly using the Elastic Stack. For this demo, we will be using the Brolly export feature. As Salman mentioned, in Brolly, we are capturing records of social media, and sometimes customers want to generate exports of their records in different formats. These exports sometimes are quite large, and some of them include thousands of records with large media files. Brolly supports 4 different formats for the export: HTML, PDF, JSON, and CSV. And each of these formats, they have their own services and their own pipeline. Here, as an example, we will be looking at the pipeline of the HTML format export. We will be adding a simple bug to one of our services in this pipeline and show you how we find and resolve the error quickly using the Elastic features. So in Brolly, if you create an HTML export and then look at the service map inside the Elastic APM and focus the service map for the HTML export pipeline, you will see the interactions of different services here. In Brolly, we are all the microservices are communicating through the Kafka messages. And in this case, export is submitted, and then creator picks up the message, and after finishing its job, it sends the compress request to the compressor service. And finally, when the export is finished, it sends a message to the notification service and sends a message to customer that the export is finished and ready to be downloaded. Now let's add a simple arithmetic exception, divide by 0 exception to our code in the export creator service. And then if after submitting a new export while having this bug in the export creator service, as you can see here that the service map has changed and it's not complete now, and the request stopped at the export creator, and it does not have the interaction with the export compressor and the notification service. So by having a quick look at the service map of the Elastic APM, you can have an idea what's going on in your infrastructure, and you can easily detect if anything is wrong. But thanks to the Elastic alerts and watchers, we receive a notification email for the failed export immediately. Based on the priority of the errors, we have set a few watchers to create actions based on a certain conditions. For the export failure, we have defined an action to send an email to the corresponding dev team with the details of the organization, user, and failed export, even the exception message. As Salman mentioned, we are adding these useful information as a context log. Log context, this helps us to find the error quickly in Brolly. As you can see in this email, the developer can see which export has failed and the export is created by which user, and without investigating the error, the developer can see what kind of exception happened in which service. And now I'm gonna switch to the Kibana tab to show a sample exception that happened in this pipeline and see how we can find the exception. So as you can see here, we have set up this watcher as an example. We have lots of watchers in Elastic to receive email if an export is failed. And this watcher sends query every 5 minutes to the error record index, where we keep all the exceptions and errors of different microservices in one Elastic index. And the query says whenever there's an exception that the original topic for that is the export, then it means something is wrong in the export pipeline. The original topic is the source that every service is messaging, getting the message So because, as I mentioned, we are using Kafka for the messaging, every service has the original topic and the destination topic. So whenever this happens, it sends an email to our dev team, and the content of the email is the log context with some useful information and even the exception message. So the developer can receive this email immediately and see how, and then after receiving that email, you can have a look at the transaction traces in the Elastic APM. This is very helpful, especially if you have microservices in place. In this case, the request is coming from Brolly UI, it goes to the export service, and then the export creator. But because of that, the exception that we added to the export creator, the exception happens and it sends the message to the dead letter queue Kafka topic. The dead letter queue is a topic that we are keeping all the failed messages to replay later after fixing the bug and issue. So by looking at this transaction traces, you can easily detect that where exactly the exception happened and how you can resolve that. Also, if you look at the discover page of the Kibana, you can find the exception here using a simple Kibana query language to find the exception. And as you can see here, we have also defined a link for each record. After fixing the bug and issue, the developer can just click on this link. It's gonna send a request to our replay handler service, and replay handler service picks up the message from the dead letter queue and send it to the corresponding Kafka topic to process the message again after fixing the issue. So I'm gonna go back to our slides here and talk about a few lessons that we have learned in Brolly using the Elastic Stack. As you saw, we added lots of useful information to our log context, and that helps us to find the errors so quickly and easily. So the more context you add, the more easier you will find the errors and resolve them. So try to contextualize the application logs as much as you can. Also, we found the APM very useful, especially if you have microservice design. By looking at the transaction tracing, you can see where the request is coming and what's happening exactly where. And also the service map. The service map helps us to have a quick view on our infrastructure and the whole microservices that we've got. And it helps us to see if there's something wrong with any of those services. And obviously, you can also monitor the performance of infrastructure using the APM. In Brolly, we have dozens of microservices, and all the errors of those microservices goes to we keep them in a single Elastic index and Kafka topic. So it's easy to find and replay them in one place without looking into the logs of different services. So unified observability is the key here. And also, by using the alerts and watchers, you can prioritize the issue by sending them to different channels, and you can proactively resolving issues and detect anomalies. Thank you for your time, and we hope you found this presentation useful. We look forward to answering any questions you might have.